NASA Starliner, History, Present, and Future. Introduction. NASA's Starliner spacecraft, developed by Boeing, marks a significant chapter in the evolution of human spaceflight. Designed to transport astronauts to and from the International Space Station (ISS), Starliner exemplifies the collaboration between government and commercial entities in advancing space exploration. This report explores the history, current status, and future prospects of the Starliner program. Historical background. Early involvement in space. Boeing's involvement in space began in 1961 when it was selected to build the SIC first stage of the Saturn V rocket, which played a crucial role in NASA's Apollo program that landed humans on the Moon. Over the decades, Boeing has contributed to various space missions, including the construction of modules for the ISS, and has been involved in numerous spacecraft projects. Development of Starliner. In 2014, NASA awarded Boeing a contract worth $4.2 billion under the Commercial Crew Program (CCP) to develop the CST-100 Starliner spacecraft. This initiative aimed to foster partnerships with private companies to transport astronauts to the ISS, thereby reducing reliance on foreign vehicles for crew transport. The development of Starliner faced several challenges. The first uncrewed test flight, known as the Orbital Flight Test (OFT-1), launched in December 2019 but failed to reach the ISS due to software issues that caused the spacecraft to misalign its orbit. Despite this setback, Boeing successfully launched OFT-2 in May 2022, demonstrating the spacecraft's capabilities. Current status. Crew Flight Test Mission. In June 2024, NASA astronauts Butch Wilmore and Suni Williams embarked on the crew flight test mission aboard Starliner. The mission aimed for an 8-day stay at the ISS, allowing the crew to conduct scientific research and operational tests. However, complications arose during the mission, including helium leaks and issues with the spacecraft's reaction control thrusters. As a result, NASA decided to return Starliner to Earth without its crew to prioritize safety and gather additional data. Wilmore and Williams were kept aboard the ISS, continuing their work until their return in February 2025 via a SpaceX Crew Dragon spacecraft. This decision underscored NASA's commitment to safety, emphasizing the inherent risks involved in spaceflight and the importance of thorough testing. Future mission plans. Following the uncrewed return of Starliner, which is scheduled for September 2024, NASA and Boeing will analyze mission data to determine necessary adjustments before proceeding with future crewed missions. NASA has outlined a plan for Starliner to complete 6 additional crew rotation flights to the ISS before its anticipated retirement in 2030. Future prospects. The role of Starliner in commercial spaceflight. As part of NASA's broader commercial crew program, Starliner represents a significant step towards establishing a sustainable human presence in low Earth orbit (LEO). The program aims to encourage private companies to develop reliable and cost-effective transportation options for astronauts, paving the way for future exploration missions to the Moon and Mars. Boeing's ongoing commitment to the Starliner program is crucial, especially as the company navigates challenges that have impacted its reputation in the aerospace sector. Despite setbacks, the Starliner spacecraft is expected to play a vital role in NASA's human spaceflight strategy, contributing to the agency's goals of deep space exploration. Implications for future exploration. Starliner's development is not just about transporting astronauts to the ISS. It also lays the groundwork for future missions beyond LEO. As NASA prepares for the Artemis program, aimed at returning humans to the Moon and eventually sending astronauts to Mars, Starliner's capabilities will be instrumental in supporting those endeavors. The successful operation of Starliner will enhance NASA's ability to conduct long-duration missions in space, provide critical data for future spacecraft development, and help build a robust commercial space industry. Conclusion: the NASA Starliner program, despite its challenges, stands as a testament to the collaboration between government and private industry in advancing human spaceflight. With a rich history and promising future, Starliner is positioned to play a pivotal role in the next era of space exploration, ensuring reliable access to the ISS and beyond. As NASA and Boeing work towards resolving current issues and preparing for future missions, the lessons learned from the Starliner program will undoubtedly influence the trajectory of human space exploration for years to come. The commitment to safety and continuous improvement will remain at the forefront, ensuring that the dreams of exploring further into the cosmos are realized. Overall, the Starliner story is one of resilience and innovation, symbolizing humanity's enduring quest to explore the final frontier. As the program evolves, it will contribute significantly to our understanding of space and our ability to thrive beyond Earth. Counterintuitive information in the NASA Starliner overview. 1. Delayed return of astronauts. Initially, the plan was for astronauts Butch Wilmore and Suni Williams to return to Earth on the Starliner after their mission to the ISS. However, due to complications such as helium leaks and control system failures, NASA decided to keep them aboard the ISS and send the Starliner back uncrewed. This represents a counterintuitive decision in space missions, where the expectation is typically for astronauts to return on the spacecraft they traveled on, highlighting a significant emphasis on safety over protocol. Public perception versus technological capability. Despite the advanced technology and capabilities of the Starliner, public perception has been adversely affected by its troubled history, particularly the failed 2019 flight test. This illustrates a counterintuitive reality in aerospace. Even a well-designed and capable spacecraft can suffer from reputational damage that impacts future missions and investments, despite the underlying technological achievements. 3. Boeing's space business uncertainty. Boeing's decision to potentially shed its space division to focus on commercial aircraft and defense systems seems contradictory to its long history of significant contributions to space exploration. This shift indicates a possible prioritization of profit-driven sectors over historical commitments to space, suggesting that even a leading aerospace company may reconsider its priorities based on recent failures and market pressures. 4. Safety over mission objectives. The decision to return Starliner without crew to gather more data, despite having astronauts ready for return, reflects a counterintuitive approach where the immediate goals of a mission returning the crew were sacrificed for the sake of comprehensive safety evaluations. This illustrates a growing trend in space exploration where safety protocols take precedence over traditional mission objectives. 5. Commercial crew programs duality. The Commercial Crew Program aims to ensure safe transportation to the ISS, yet it also exposes the vulnerabilities of commercial partnerships in space exploration. The expectation of reliability in commercial contracts contrasts sharply with the reality of delays and technical challenges faced by Boeing, highlighting a paradox where commercial endeavors are supposed to enhance efficiency but can also lead to setbacks. Historical success versus current challenges. Boeing's rich history of successful missions, including contributions to the Apollo program and the ISS, stands in stark contrast to the current challenges faced with the Starliner. This juxtaposition is counterintuitive. A company with such a successful track record in aerospace is now grappling with technological failures and negative press, which can lead to questioning its future role in space exploration. 7. Autonomous operations versus human oversight. Starliner's design emphasizes autonomous operations, yet the reliance on human oversight during critical phases of the mission illustrates a counterintuitive reliance on human decision-making in an era of advanced automation. The expectation of fully autonomous systems clashes with the reality that human judgment remains vital in complex, high-stakes environments like spaceflight. 8. Perception of routine operations. The expectation that spaceflight should become routine and less risky contradicts the inherent unpredictability and danger of space missions. NASA's acknowledgement that spaceflight is risky, even at its safest and most routine, challenges the notion that advancements in technology will lead to a risk-free environment in space travel. 9. Impact of ground testing on flight safety. The extensive ground testing and simulations that Boeing and NASA engaged in prior to the crewed flight did not fully predict the issues that arose during the Starliner mission. This presents a counterintuitive situation where thorough preparations did not translate to successful operational outcomes, emphasizing the unpredictability of actual flight scenarios compared to controlled testing environments. 10. Boeing's past contributions versus current scrutiny. Boeing's legacy in space exploration, including the construction of the Saturn V rocket and the ISS, is overshadowed by recent failures and scrutiny. This presents a counterintuitive narrative where a company's historical successes may not provide a safeguard against current operational challenges and public perception issues, illustrating how quickly the narrative can shift in the face of failure. These points reveal the complexities and often counterintuitive nature of the aerospace industry, where historical achievements can be quickly forgotten in light of new challenges, and the pursuit of safety can lead to unexpected operational decisions. The NASA Starliner program, developed by Boeing, is a significant part of the United States' efforts to maintain a human presence in low Earth orbit and to prepare for future exploration missions. While many aspects of the program have been extensively reported, there are several key elements that may be overlooked by the public but are crucial for understanding the implications of the Starliner project. 1. Historical context and legacy of Boeing in space. Boeing's involvement in space exploration dates back to the 1960s with the Saturn V rocket, which played a crucial role in the Apollo moon missions. This historical context is significant as it highlights Boeing's long-standing commitment to space exploration and technology. The failures and challenges faced by Starliner are not just technical setbacks. They reflect on Boeing's legacy and its ability to innovate and adapt in a competitive aerospace industry. Understanding this legacy can provide insights into the pressures Boeing faces as it navigates the challenges of the Starliner program amidst public scrutiny and competition from companies like SpaceX. Here, safety culture and decision-making. The decision to return Starliner to Earth without a crew due to helium leaks and control system failures reveals a critical aspect of NASA's and Boeing's safety culture. This decision underscores a commitment to prioritizing astronaut safety over mission completion. While the emphasis on safety may be noted, the significance lies in how it reflects a thorough approach to risk management in human spaceflight. This culture is vital in ensuring the long-term success and reliability of space missions, but it also highlights the challenges of balancing innovation with safety requirements. 3. Importance of data collection and analysis. NASA's and Boeing's focus on gathering data during uncrewed missions is often overshadowed by discussions about crewed flights. However, this data is essential for understanding spacecraft performance and informing future designs and operational protocols. The insights gained from the uncrewed return of Starliner, will contribute to enhancing the safety and reliability of subsequent crewed missions. This iterative process of testing and analysis is fundamental to the advancement of aerospace technology. 4 implications for future missions. Boeing is tasked with completing 6 more crewed flights before the ISS is decommissioned in 2030. This timeline places immense pressure on the Starliner program to resolve existing issues and demonstrate reliability. The significance of this timeline cannot be overstated. It affects not only Boeing's future in the space sector, but also NASA's broader goals for human exploration, including Artemis missions to the Moon and Mars. The success of Starliner is thus intertwined with the agency's aspirations for future exploration. 5. The Commercial Crew Program's broader impact. The NASA Commercial Crew Program, which includes Starliner, is pivotal in fostering a competitive landscape for human spaceflight. The program's emphasis on collaboration with private companies is a strategic move to reduce costs and encourage innovation. However, the challenges faced by Starliner may prompt discussions about the viability of this model and its impact on future partnerships. Understanding this broader context is important for recognizing how the outcomes of the Starliner program could shape the future of commercial space travel and international cooperation in space exploration. 6. Public perception and corporate reputation. The negative publicity surrounding Starliner, particularly in light of Boeing's previous issues with the 737 MAX, raises questions about public trust in aerospace companies. While technical failures can happen, the way these issues are communicated and addressed can significantly impact public perception and corporate reputation. The long-term success of the Starliner program is not just about meeting technical milestones. It is also about restoring confidence in Boeing as a reliable partner for NASA and the future of space exploration. 7. Technological innovations and future applications. The technological advancements developed for the Starliner program may have applications beyond just crew transport to the ISS. Innovations in autonomous systems, life support technologies, and spacecraft design could inform future missions to the Moon, Mars, and beyond. This potential for cross-disciplinary applications is often overlooked but is crucial for maximizing the return on investment in space exploration technologies. 8. The role of international partnerships. While the focus is often on American companies and spacecraft, the Starliner program is part of a larger international collaboration framework for the ISS and future lunar missions. The implications of Starliner's success or failure extend to international partners who rely on a robust American space program for their own missions. This interconnectedness highlights the importance of reliability in the Starliner program as it affects not only U.S. interests but also global partnerships in space. In conclusion, while the NASA Starliner program's challenges and milestones are well documented, the broader implications of these events are often overlooked. The historical context, safety culture, data-driven decision-making, and the program's impact on future exploration all play significant roles in shaping the future of human spaceflight. Understanding these dimensions is essential for grasping the true significance of the Starliner program within the larger narrative of space exploration and technological advancement. The NASA Starliner program represents a significant chapter in the history of human spaceflight, involving a blend of technological innovation, historical context, and future aspirations. Here are the 4 most valuable points for in-depth analysis and discussion. 1. Historical significance and legacy of Boeing in space exploration. Boeing's involvement in space exploration dates back to the 1960s, notably with the Saturn V rocket, which was instrumental in the Apollo lunar missions. This historical context is essential as it showcases Boeing's long-standing relationship with NASA and its contributions to both crewed and uncrewed space missions. The evolution of Boeing's space program, including the development of the Starliner, reflects both its successes and challenges over decades. Analyzing this point allows for a deeper understanding of how historical achievements shape current aerospace endeavors and the implications for Boeing's future in the industry. 2. Challenges faced during Starliner development. The Starliner program has encountered significant hurdles, notably the failure of its first uncrewed test flight in 2019 and the subsequent issues during the crew flight test in June 2024. These challenges, including propulsion faults and helium leaks, underscore the complexities of developing reliable space vehicles. A thorough analysis of these technical setbacks is crucial for understanding the risks associated with human spaceflight and the rigorous standards required for safety and performance. This aspect also highlights the iterative nature of aerospace engineering, where failures can lead to improvements and innovations. 3. Commercial Crew Program and its impact on future space missions. NASA's Commercial Crew Program, which includes the Starliner, is pivotal for ensuring safe and reliable transportation to the International Space Station (ISS). The program's collaboration with private aerospace companies aims to foster a competitive environment that can drive innovation and reduce costs. Discussing the implications of this program for future missions, including lunar and Mars exploration under the Artemis initiative, provides insights into how commercial partnerships are reshaping the landscape of space exploration. This point also raises questions about the sustainability and viability of such collaborations in the long term. 4. Future prospects and strategic goals of NASA and Boeing. Looking ahead, the planned missions for the Starliner, including the need to complete 6 crew rotation flights before the ISS is decommissioned in 2030, present strategic goals for both NASA and Boeing. Analyzing these future prospects allows for exploration into how Starliner fits into the broader context of human space exploration, including the Artemis missions and potential Mars missions. This discussion can also cover the implications of Boeing's future in the aerospace sector, especially in light of recent discussions about possibly divesting its space business. Understanding these dynamics is key to anticipating the trajectory of human spaceflight and the role that established aerospace giants like Boeing will play in it. These 4 points provide a comprehensive framework for analyzing the multifaceted narrative of NASA's Starliner program, reflecting on its historical roots, current challenges, commercial implications, and future aspirations. Space Shuttle Challenger disaster. 586. The Challenger disaster on January 28, 1986, was a tragic event in NASA's history when the Space Shuttle Challenger OV-099 broke apart 73 seconds into its flight, leading to the deaths of all 7 crew members aboard. The disaster was attributed to the failure of an O-ring seal in its right solid rocket booster SRB due to unusually cold weather at the time of launch. This incident raised significant concerns regarding NASA's safety protocols and decision-making processes, ultimately leading to a reevaluation of the shuttle program and significant changes in safety procedures. The event had a lasting impact on NASA's approach to human spaceflight, emphasizing the importance of safety over schedule and the need for rigorous testing and assessment of new technologies. Apollo 13 mission 1970. The Apollo 13 mission, launched on April 11, 1970, was intended to land on the Moon but became a dramatic struggle for survival after an oxygen tank exploded 2 days into the flight. The explosion caused a critical failure of the spacecraft systems, leading to a life-threatening situation for the astronauts. The mission was transformed from a lunar landing to a rescue operation, showcasing the ingenuity and teamwork of NASA's ground control and the crew. The phrase "Houston, we have a problem" became iconic, symbolizing the challenges and risks of space travel. The successful return of the Apollo 13 crew emphasized the need for robust contingency planning and the ability to adapt to unforeseen circumstances in space missions. 3. Columbia Disaster 2003 The Space Shuttle Columbia disaster occurred on February 1, 2003, when the shuttle disintegrated upon re-entry into the Earth's atmosphere, resulting in the deaths of all 7 astronauts on board. The investigation revealed that damaged thermal protection tiles, caused by foam insulation debris striking the shuttle during launch, led to the loss of the vehicle. The Columbia Accident Investigation Board (CAB) highlighted systemic issues within NASA regarding safety culture, communication, and risk assessment. This tragedy prompted extensive changes within NASA, including improvements in shuttle design, enhanced safety protocols, and a renewed focus on risk management in all aspects of space exploration. The Columbia disaster underscored the inherent dangers of human spaceflight and the critical importance of safety in aerospace operations. NASA Starliner 历史、现状与未来展望。NASA 的 Starliner 飞船是由波音公司开发的一款载人航天器，旨在为国际空间站 ISS 提供安全可靠的宇航员运输服务。自2014年与 NASA 签订合同以来， Starliner 经历了一系列的挑战与进展，下面将探讨其历史、现状以及未来展望。历史背景：波音在航天领域的参与可以追溯到1961年，当时它被选为土星5号火箭的 SIC 级推进段的制造商。波音不仅在阿波罗计划中发挥了重要作用，还制造了多种无人探测器和国际空间站的多个模块。2014年，波音获得价值42亿美元的合同，以开发 Starliner 飞船，旨在支持 NASA 的商业载人航天计划。Starliner 的首个无人测试飞行于2019年进行，但未能顺利到达国际空间站。2022年 ，Starliner 成功完成了第2次无人测试飞行 ，OFT-2，为后续的载人飞行奠定了基础。现状：截至2024年。NASA 和波音的团队正在进行 Starliner 的载人飞行准备。2024年6月，宇航员 Butch Wilmore 和 Suni Williams 乘坐 Starliner 前往国际空间站进行为期8天的科研任务。然而，飞行过程中出现了氦气泄漏和反应控制系统故障 ，NASA 决定将 Starliner 空载返回地球，以降低风险并进一步收集测试数据。当前Wilmore 和 Williams 计划在2025年2月通过另一艘 SpaceX 的龙飞船返回地球。未来展望：一、安全性及性能验证。NASA 计划在 Starliner 于2024年9月空载返回地球后，进行更多的飞行测试和数据分析，以满足载人飞行的安全和性能要求。Starliner 需要在2030年国际空间站退役之前，完成6次载人轮换飞行。2、商业航天计划的角色。Starliner 的成功与否将直接影响 NASA 的商业载人航天计划，确保美国能够在未来进行更深层次的太空探索，包括月球和火星的任务。NASA 的目标是与美国航天工业合作，确保宇航员能够从美国土壤安全发射进入低地球轨道。3、航天领域的持续挑战。尽管 Starliner 项目显示出一定的潜力，但波音在航天领域的未来仍面临挑战。近期有报道称，波音可能会考虑剥离其航天业务，以专注于商业航空和防务系统。这可能会影响到 Starliner 的后续发展和运营能力。结论：尽管 Starliner 项目经历了多次挑战与延误，波音和 NASA 的团队仍在努力确保飞行安全，并为未来的载人航天任务做好准备。通过持续的测试和改进， Starliner 有望在未来的商业航天活动中发挥重要作用。随着 NASA 的商业载人计划不断推进， Starliner 的成功将为人类探索更远太空提供关键支持。